Hi, morning. So in this video we're gonna talk about more about voltage regulator. So if you're here, maybe God had given you wisdom, maybe from your family, maybe from family, maybe from your family, maybe from your friends, or might any outsider. Okay, so what is voltage regulator basically? Basically, voltage regulator take an input voltage and convert it to the high or low output voltage. That's it about voltage regulator. So in this particular case, we will more focus in LM7805, which is a voltage regulator. So basically, I'm using LM7805 voltage regulator. So LM7805 consists of pin 1, which is input, pin 2, which is GND ground, pin 3, which is the output, and it came in with the surface mount device as well. So basically the 78 series, which we got 7805, which is 5 volt, 7806, which is 6 volt, the back number which is indicate the output voltage. Here we got the schematic part here for the LM7805. Here for the configuration, which we consist the LM7805 consists of 2 electrolytic capacitor for filtering purpose. So right here we got a theory question which we will be learn together about LM317. The component is different, which we will be using in the theory, but somehow it's the configuration is the same. We got 2 capacitor as the filtering purpose, and it add on voltage divider here, which is R1 and R2, and we got some sort of potentiometer which we can vary the value from 0 to maximum, which is 5 kilo ohm, and we got a C3 here as well for filtering purpose. Then we got a voltage output here, 35 volt input. Then we will calculate what is the output for this schematic here, right? So here is said determine the minimum and maximum of the output voltage. So we have to calculate the minimum and the maximum voltage, which is what is when the 0 ohm, and what is R2. We can calculate when the R2 is 0 ohm, and we will calculate the R2 when is 5 kilo ohm. Alright, so somehow this is the formula here. So we will use this formula to calculate what is the V out for the situation, whether it is 0 ohm or 5 kilo ohm. Okay, let's calculate it. Okay, somehow this is the theory question here. Determine the minimum and the maximum output voltage for the voltage regulator, which is in the figure we can see here. Assume current adjustment, this is ADG, is current adjustment is 50 microampere. Alright, somehow we got the formula here, which is V out equals to V reference times 1 plus R2 or R1, and plus with the current adjustment times with the R2, which is 5 kilo ohm. Alright, so let's do. Alright, based on the formula here, which is V out equals V ref plus over this. Alright, so it's V out equals to V reference, you know, is 1.25 times 1 plus R2, which is 0 volt, R1 we need take here, which is 220 ohm. Alright, so plus with current adjustment, which is 50 microampere, and R2, which is 0, right? So we just kind of will cancel out this, we cancel out this, so we know that voltage output is 1.25 times 1, so it's 1.25 volt. So we're done with the minimum voltage here for the output voltage. Now we go for the R2 here, same, V out equals 1.25 1 plus, in this particular case R2 is 5 kilo ohm, so 5 kilo ohm over 220 ohm plus 50 microampere, alright, times with the R2 which is 5 kilo ohm. So let's calculate it. We got, how much is it? 50 microampere, 50 micro times 5 kilo. So we got 0.25 here, 1.25 plus with 0.25. 1 plus 5 kilo ohm, how much? 5 kilo ohm divide 220. So 5 kilo ohm divide 220 plus 1. So we got 23.72. So somehow times 1.25 plus 0.25, so we got 30 volt output. This is somehow the theory part here. 1.25 times 33.72 plus 0.25, we got 30 volt here. Alright, so the V out when the R2 maximum is 30 volt. So somehow just now the theory part is 35 volt, kind of step down to 30 volt when it's the 5 kilo ohm is maximum here. This is sort of like a potentiometer, which you can adjust the resistance there. So we got 30 volt. So somehow this is like more like to step down voltage regulator, right? Because it starts from 35 volt V in to V out, which is 30 volt. Okay, let's go to the experiment part here. Hi, so this is somehow the experiment part which we'll be conducting here. We're using L7805, not LM, right? It's L7805 voltage regulator here. Then we got a 2 filtering capacitor here, somehow rated 470 microfarad, and another one is 47 microfarad. Then in parallel, this capacitor is R1, which is 1 kilo ohm, and which is LED here, which is in a green color, which is a voltage drop around 0.9 volt, around that side, bit higher than the red LED. Alright, so we got an input. We supply in the experiment part, we supply 9 voltage, but this regulator can handle 7 volt to the 24 volt DC. Alright, but in particular case, we're using battery which is 9 volt going into the voltage regulator here. Then we will be getting 5 volt at the end, another side, which is a V output. Alright, so let's do some experiment here. I'll show you how it's done. Here's the voltage regulator for the breadboard, which I already done. Is do it for the Solaris breadboard first. Okay, somehow when I'm done with the Solaris breadboard, I already have a confidence in it, which I get 9 volt to the 5 volt. Then I make it as perf volt, which is the permanent electronic project for me lah. So this is the battery, which is 9 volt battery. Somehow I connected it to the caps here. And completed the perf board. I make it as terminal block here so I can make it a set of like a electronic project for me. Okay, so I got a red to the here, capacitor red leads to the capacitor red leads, right? So I put it here. I think here should be fine. And then black leads here. Okay, you see the LED light up means the circuit in a closed loop. Somehow we will get the voltage at the output, which I'll be putting on the caps there, because the caps is near the output there. So I will get the value. I have this. So I put red lead at here, black lead at another side. So rated 5 volt there, you see. So output is 5 volt and input is 9 volt. So somehow we already we make it 9 volt to the 5 volt there. Alright, somehow we can convert 9 volt to the 5 volt there. Okay, that's about it. So we're done with it. Now I just want to share my thoughts on the datasheet for L7805 Voltage Regulator. Alright. So hi friends, this is our datasheet, which is L7800 series from the ST Electronic here. You can see you don't necessarily have to print out like this. Is around 48 page, which I print out here, around 48 page. So this is just for me, for like learning purpose for me. So somehow you can download it as a PDF. You just you can go through like that. No, then not necessarily have to print it like this. So I just want to share my thoughts here. So somehow this is a TO220, which is positive voltage regulator, which we're using just now for the experiment part there. This is the L7800 series. You can see here I got a thermal overload protection, short circuit protection, output transistor SOA protection. Okay, let's I just want to walk through the voltage regulator datasheet. You can see what's going on in here. So this is the so you can see here through down here we got the L7800 series. Then somehow this is the schematic diagram for the voltage regulator. Somehow the engineer called this as a block. This is the block for like a block diagram. They call it as block diagram. Now the particular schematic diagram, somehow they make it as a block for the how is the process between the, let's say, the starting circuit here. Then we got a reference voltage, current generator, error amplifier, and a SOA protection, thermal protection, series pass element, and so on. Then you got two resistors. Somehow it's voltage divider here. Somehow we make it as electric circuit, make it simple in a block diagram. That's some sort of they're showing here. That's what is the block diagram means. Okay, got the content here, pin configuration. This is the best part here. It's shown the internal structure of the voltage regulator. Somehow it's just a combination of diodes, resistor, bunch of resistor. You got a transistor as well, NPN, PNP, and you got a capacitor also. So it's just a bunch of components, but they didn't list out what is the R1, how much the ohm, because that is, I think, quite confidential for the company to share it. What's the R1, what's the R2, the value, what's the transistor they're using. Somehow this is a very good for, if let's say you want to build your own voltage regulator, this is kind of your reference here. If you can make it, that is very cool. So this is the maximum rating here. We got the DC input voltage, which is 35 volt. You can handle out. Output current is limited. This is the configuration, which is application circuit, which is L78 series. Then you do the caps 0.33 microfarad and 0.1 microfarad. They're using those caps for the application circuit there. Okay, then you got DC parameter, load regulation. They got the datasheet for load regulation, ripple rejection. Okay, and much more. The electric characteristic. Okay, this particular part for the electric characteristic is when the voltage input 10 volt, then this is the datasheet they got. Let's say it's 11 volt input voltage. Then we get other datasheet. Got the output voltage, line regulation, load regulation, quiescent current. This is somehow the current for the transistor, current change, output voltage drift, output noise voltage, supply voltage reduction, and much more. Okay, this is let's say the V input is 14 volt. Then we got a minimum of 7.7 output voltage. And we got a max as well as 8.3 voltage, and the second circumstances to show what's going on in the. So the voltage somehow input is just increasing. Show what data we can get. All right. I think that's about it. I just want to show the basic basic of what's going on the voltage regulator. Okay, so this is somehow if you got oscilloscope, you can get it the typical performance for the voltage regulator. Got the dropper voltage, basic junction, temperature, and much more. Supply voltage, rejection. This is all the R&D. They done all the electronic engineer done. They did done testing for the voltage regulator part there. See, we got a fixed output voltage output regulator. It's the same thing. Okay, and much more going on. Current regulator. We can make it as current regulator as well. Added our R1 here. Added a potentiometer here, and much more we can do. Increase the voltage, output voltage to two caps here. Then we got the R1 and R2 as voltage divider. Then we can increase the output voltage. And that's the kind of basic I just want to show for the data sheet. This is a nice part which we convert AC to the DC. This is a negative output voltage circuit. Let's say we want to make, let's say we're using different L78 series which is negative format. So we can convert from AC to DC with bridge rectifier. This is what we call bridge rectifier, which is a combination of 4 diodes here. We convert AC to DC here, alright. Then you got a switching regulator here, much more. Remote shutdown. Light controller. Let's say if you want to build a light controller, see you got the LDR here. You got a transistor. We got a two resistor. Make it as voltage divider here. And this is potentiometer, which is the resistor we can vary here. All right. Much more application we can based on the data sheet for our project. That's what data sheet for make it for us. Oh, let's say this is for the mechanical data part. For the mechanical data part, somehow they draw it in AutoCAD. Just how much the dimension, all those stuff. That's about it, I think. This is quite a kind of big page, around 48 pages. All is the mechanical data here. Yeah. And you get the last update is on 2000. This is the revision history for the data sheet for the ST Electronics. Somehow last update on 2006. Okay, that's about it, guys, for the data sheet. Nothing much. I just want to show some basic stuff. Okay, data sheet is just a reference for you when you build your own electronic project. Somehow you have to use data sheet, just show what's the value, somehow how much the value for use. Let's say some voltage regulator should be used in 0.1 microfarad and 1 microfarad for the L78 series. Somehow the data sheet is just a reference for us when we do our electronic project. Okay guys, that's about it. Thanks for watching. Hope you learned something. See you in the next video. Bye.